Hi everyone, Mr. Armitage here in video 2 of the Unit 4, Chapter 5 Min-Unit Test Exam Review. Okay, so video 2, question 2 here, and my notice audio is a little bit different, right? I still playing around with the settings. I haven't used this computer. Well, all my settings got wiped a while ago, so I haven't set everything up again for quite a while. Okay, so let's take a look here. Right. Following tree diagram was used as part of an experiment on the effectiveness of a new medication. Great. So first question A, right? We see this tree diagram here. We have cured, not cured, cured, not cured. We have medicine or the sugar pill, also called a placebo. You remember from our experimental design unit last semester. Okay. What is the probability that a random person in the study was cured given that they were assigned to take the medicine? Okay, so that's an important thing to remember, given that they were assigned to take the medicine. Okay, so given we are here, that is where we are starting. Okay, what is the probability that they were cured? Okay. Well, to get from medicine to cured, there's only one path we have to take. Right there. Okay. Now, I'm going to go ahead and use the proper probability notation just so we can kind of see what that looks like in this case. Okay, so I'm going to call this medicine. And of course, the sugar pill will be not medicine, or medicine's complement. Okay, here we have cured. We have not cured. I'm sorry for all the C's. Okay, cured. And behind my video, you can't see this, but I guess trust me, there you go. Okay, not cured. There we go. Okay. So here, given that they were assigned to take the medicine, probability that they were cured. So we are looking at probability that they are cured given that they were assigned medicine. Okay, so, right, given that we were there, we go. Okay, so that's just 3/5. Right, 3/5 or 0.6 or 60%. Either one is good. Okay, sorry, I'm not redoing the video. Just gonna have to live with that. Okay. Next, what is the probability that a random person was cured? So the only thing that we are looking at is just being cured. Okay. Now we have two ways of doing that. Right? We could, well now, right, we could have the medicine, or we could have not medicine. Right? We could have the sugar pill, the placebo. So in order to add these together, right, we said or, and or refers to addition, right? We could be this cured, or we could be this cured, right? Two different types of cures. In order to add them together, we have to see, okay, well, where do they combine? And so they combine up at the very origin, right here. So we go this way, and that's 1/2. And I'll write the probability notation afterwards. 1/2. And then through medicine to the end, to this cured here. So times 3/5. And now we are jumping a branch. So we're going this way. Okay, so that's going to be a plus another 1/2, because that's the probability there. And now we are going this way, 1/10. There we go. Okay, so simplifying these out, we end up with, well, let's see, right, 3/10 plus 1/20. Okay. That's going to equal 7/20, right? Find a common denominator, all that fun stuff. So that gives us 0.35 or 35%. Okay, so there's a 35% rate chance that we would be cured. Okay. Probability notation for this, okay, right? We could have the medicine and be cured, or we could not have the medicine and be cured. Sorry for the little abbreviation for and, don't have a whole lot of space. So that or looks like addition, which is what we had right there. Okay. Now the next one. Okay. We are given that a random person was cured. Okay, so probability notation wise, we are saying given that someone is cured. So I'm just going to kind of write it there off to the side. What is the probability that they received the medicine? So that we are kind of there. So let's see here, medicine. Okay, well, one of the things to check for a tree is this thing that we are given a possible place to start? And we see no, right? We have two different cured spots, and we can't go forward or we can't go down. Okay, we can only move one direction in a tree, so we can't go any further from these two spots, so we can't do this. So then we have to remember, in a sense, that we are talking about the intersection of the two, so medicine and cured divided by probability that they are cured. Now, visually, it's a lot easier, okay? Because visually, right, we have two branches, okay? So the two branches, okay, we have cured that represent the two branches. So there we go, 0.35. And up above, okay, this is the branch we're interested in because this is the branch that contains the medicine. Okay, so this is the branch that represents the intersection here. So that's going to be 0.3. You want to know where that came from? That's 3/10. Okay, so 0.3 divided by 0.35. Okay, and that gives us 0.857 or 85.7%. So there we go. Okay, so that's C. Now for D, okay, we're asked effectively the same question, but now we are looking at it from a different given. Right? So we're saying given that they were not cured. Sorry for the no there. Okay. So the not cured are all here. So we're going to need to find the probability that they're not cured. Okay. And we're going to follow the same pattern as before. Okay. That they receive the sugar pill. So we're looking at this. Given that they are not cured. There we go. So not cured is going to be following the tree, okay, 1/2 times 2/5 times 2/5 plus okay, this branch here, 1/2 times 9/10. And that should be fairly clear, right? Right, you're more likely to not be cured if you're not receiving the medicine. Hopefully, if the medicine's effective. Keep that in mind for the next question. Okay? And the branch that does not have the medicine, right, the branch that has the sugar pill, is now this one. So we're going to use this branch divided by the overall branches. Okay? So that is the 1/2 times 9/10. Okay, so working that out, we get 9 over 20 over. I'm going to say 4 over 20, just simplify right away. It's 9 over 20. So we got 9 over 20 out of 13 over 20. That's going to simplify down to 9 over 13, or 0.692. So 69.2%. Oops, there you go. Sorry, I have everything on another screen there. Okay. So remember, this part here came from those branches there, and this part here came from these branches here for being cured. It's one of the downsides for trees, in that if we want to use a given that's not our first decision here, it can be a little tedious, but that's fine because we can do it mathematically. Now for E, okay, given your answers to the previous questions, okay, does it appear that the medication is effective in curing people? Explain your reasoning. Is medicine independent of being cured? Okay, that's effectively the question here. Right? So if we look at, right, we have a 60% chance of being cured if we have the medicine, but only a 10% chance of being cured if we don't have the medicine. Okay? So we're asking really, are these two events independent, medicine and being cured? Okay? And well, we can see, right, these branches here are not the same probabilities as these branches here. That's independence, or not independence, okay? We can tell by these two branches that these are not independent. Therefore, this medication is effective because having the medicine changes your probability of being cured. Right? Hopefully, I will see you in video 3, maybe. We'll see if I get to record it today.